Good morning and welcome to Code and Coffee. This is Brian Selby, your host. I'll be walking you through a modeling demonstration using CBECC-Res today. I want to say thank you to our sponsors, Energy Code ACE. If you're not familiar with Energy Code ACE, check out the website energycodeace.com, and we have lots of information for you. We have resources, fact sheets, trigger sheets, checklists. We have application guides, an abundance of information. Granted, most of it's relative to the 2016 code, but we're coming out with 2019 code reference material. We also have training, many different modalities of training you can check out, as well as some tools. I'm going to be demonstrating one of our most popular tools today during the show. So I welcome you to grab a cup of coffee and settle in for a live demonstration modeling a simple residential new construction project. All right, as I mentioned in the pre-show, this project may look very familiar to you. I did this in my very first episode of Code and Coffee. It is a simple residential single-family, single-story project, but I'm doing it today with the CBECC-Res software. My very first episode, I did it with Energy Pro. So we're going to be using CBECC-Res. I'll be using the Bluebeam software. That's the software that I use to do my takeoffs, but it's not necessary. You could use an Adobe product or some other product to do that. So this is an interactive show, so I encourage you to type questions and in the chat window. I try to respond to all the questions. I see a few more people have logged in. Kit is here. Good morning. And Bobby says audio is barely legible. We might have a fix for that, Bobby, if you go and force the YouTube to deliver at 720 DPI, or I'm not sure, my tech manager tells me all this stuff. It may improve the quality of the video and the quality of the audio. So, all right, let's take a look here at what we have for a project. Now, this is a client of mine, Keith Designs. Rob, if you're listening, thank you for the use of your plans. This is a real project that I did a while back. So let's just do an initial project assessment, see what we're looking at. We've got a project, looks like it's on a pretty large estate lot. And we'll see in here our plot plan. I've taken the liberty of doing some of the takeoffs ahead of time just to save time. This is our floor plan. Again, this might look familiar. So single family, attached garage, pretty simple box. So we'll be looking through this. A couple other things I want to look at is we'll look at the elevation, kind of see what kind of materials I'm looking at. We've got wood siding, we've got some metal roof, we've got some vaulted ceilings, looks like. We'll grab some information there off of the sections. So here's our ceiling height, our vaulted ceiling there. So yeah, we'll dive into this and get some more information. Now, for the sake of time, I've gone ahead and determined what all of the inputs are going to be for our assemblies and for our HVAC systems. So follow along and let me know if I made any mistakes or forgotten anything. Hey, this is what this is all about. You're getting a real live view here. So our project, I just like to point this out. I had some comments on some previous episodes about orientation. So orientation on a project is based off of a 360-degree azimuth, so north being 0, and the orientation goes clockwise. The front orientation is the orientation you'd be looking at is if you were standing at the front door looking out. So in this case, north is to the top of the page. You can see here where my cursor is. It's 143 degrees. So this is kind of south by southeast facing. So the front's not due south, but 143 degrees. So I'm going to start doing my takeoff here. So the front is 143, and it's real easy. We only have 4 cardinal orientations. So 143, and we just add 90 degrees to that. It's going to get all four of our um, facets or faces of our building. So 143, my left orientation is 233. That's degrees. Add 90 to that. My back orientation is 323 degrees. If I add 90 to that and then subtract 360, it's going to bring me back around to 53 degrees to my right side. So pretty simple there. Let's go ahead and jump into our floor plan. Now, I went ahead and calibrated Bluebeam to my plan scale here. That way I could generate linear dimensions and areas. So pretty simple. Just hit the calibrate tool, grab a known dimension. And the beauty of Bluebeam is that you can click on endpoints and that little cursor snaps to that endpoint. Tell it that it's 18 feet. And boom, we've got our calibration. I always like to go back through and verify that when I calibrated it, it's actually measuring that. So yeah, so in this case, everything's working good. I went ahead and calculated my area as 1,638 square feet. And just to give you an idea here, I'm going to do my over-the-shoulder camera shot here. And you can see what I'm doing. I just do my takeoffs on a simple piece of quad paper. I orient my information based on the relative page layout. So my front takeoffs are on that portion. My left takeoffs are over there. My rear takeoffs over here. And my right takeoffs over here. Just keep it real simple. Now, some of you may have been in some of my modeling classes or the CEA exam prep classes. I've got a really nice project information worksheet. That also works really well. But today we're just going to keep it simple. This is how I do it. So I'm going to write my areas up here in the upper left-hand corner. My house is 1,638 square feet. And let me go back to this screen. My garage is 774 square feet. Now, this is a slab on grade project. So I also need to determine my perimeter for the slab. So at this point, I'm going to just grab this information. My perimeter to the house, which starts in this front corner right here and goes all the way around the house and goes to where it butts into the garage. I have 164 lineal feet of slab on the house. Now, I don't count the slab edge where it butts up against the garage because in all truth, there is not a slab edge there. So now technically we have a 6-inch step. You know, I might consider including it, you know, in this case, because it is a step down, there is some slab edge there and we would have some heat loss on that. So if you want to add that extra, what is that, 15 and a half, 16, 22 feet, we could. So that would make it 164 and 22 is 186 lineal feet. You can do that. Let's take it our slab edge perimeter of our garage. I've already done that. That's 89 lineal feet. You can see that dimension right here. So the slab is 774 and 89 lineal feet of slab edge. Good. I've got my initial slab area takeoff. Pretty simple here. We're going to jump into our wall takeoffs. Now, this designer has indicated that the ceiling height is 9 feet. We do have a vault. Everything else is flat. So what we're going to do here is take our wall dimension, which it's clearly dimensioned down here is 50 feet from the edge of the garage to the edge of that wall. So 50 times 9 is going to be 450 square feet of front wall. We're just going to move our way around the project. We've got 28 feet of left wall. Now keep in mind that this wall, and this wall are all in the same orientation, although they're not in the same plane. Now, if they're all the same configuration, meaning that the assembly is the same, we can include that as all one area. It's all facing the same direction. So 28 times 9 is 252 square feet. Working our way to the back elevation. Again, I'm going by printed dimensions rather than scaling dimensions. In this case, 66 feet from this point all the way over to this point. You got to be careful with some projects. You might have some odd dimensions or walls that may be way out of plane, and it's really easy to overlook that stuff. So keep an eye out for that. So in this case, it's pretty simple. 66 times 9 feet is 594. But one thing I want to point out, we do have a vault in here. Now, this ceiling vault on that diagram is not correct. I want to go to the sections. What I'm talking about is the exterior wall that is above that 9-foot plate over here. We want to get an idea of what that vault is. And I'm going to go to my cross section, and you'll see this. This is the great room looking out. I've got an extra 23 square feet above and beyond the 9-foot plate. So I'm going to add 23 to that number. I get 617 square feet for my rear wall. Let me know if you didn't follow along with that. I can clarify that for you. Good, so our back wall's done. We just need to collect the information for the right wall, and that's our dimensions 19 feet plus the additional 2 feet. So 21 feet times 9 gives us 189 square feet. So good, we've got our house, our conditioned space, wall takeoffs done. Let's grab our garage. Now you can do this in any order you like. You can grab the wall information for wall areas on the front and then also grab the windows. I like to go through and do all of our parent objects, meaning all of our walls first. Then I'll go back and do all the windows. So however you like to do it, let me know in the chat window if you like to do walls and then all windows, or do wall and window at the same time for each orientation. So I'm really curious to see people's processes. So our garage here, technically we got to have a 6-inch step down in that garage, so it's 9'6" for our garage. So we have 28 feet on our front wall, 9.5 feet gives us 266 square feet. For our front wall, we've got 21 lineal feet for our left wall, 9.5 times gives us 100. It's 199.5. I want to round that to 200. You could input the decimal. That's all cool. Let's go ahead and grab our back wall. This is a little 12-foot projection. You see how I'm breaking out the wall area specific to the zone that I'm in. Right now I'm in the unconditioned garage zone, and I only have 12 feet of rear wall in the garage zone. So if I have 12 times 9.5, that gives me 114 square feet. And you can see I'm going to do my over-the-shoulder shot. I'm just going through and updating this stuff. Now I have done some takeoffs ahead of time, so I'm just trying to expedite this for everybody. And my right wall is another 28 feet, so that's the same as my front wall, 266 square feet. Now let's look at, to finish out our vertical wall surfaces, we have a demising wall that is between the conditioned house and the unconditioned garage. This is not specific to an orientation. So I see Olivier does floors, walls, roofs, windows. Good. Yeah, that's kind of the same process I do. Kind of dealing with all the parent objects first and then drilling down to the dependent objects, or so you'll know what I'm talking about when I start inputting this information into CBECC-Res. So I went ahead and dimensioned these walls. I have 15.5 feet for that wall, 6.5 feet for that wall. That gives us 22 feet overall. A 9-foot plate, multiple that times 9, I should have 198 square feet. And that wall is going to be, that wall belongs to the conditioned area, and it will be adjacent to the garage area. That'll make sense when we start doing our inputs here. So let's start gathering some openings. So we'll start with our front. Now I like to gather my information starting with the front wall and working clockwise. just like I gathered our walls. And I like to start with the right wall and again, go towards my left. Always go clockwise. So we've got, I'm zooming in here, I've got two 2.6, 3.6 windows. Since those look like they're molded together, I'm going to call that a 5.036. So 5 times 3.5 gives us 17.5 square feet. Now we've got a situation here. We have a 3.068 entry door system with sidelights with an overall opening of 5'10" by 8 foot. I'm going to go to the elevation and get some dimensions here because I don't really have enough information on the plan to figure that out. So it looks like they're getting a sidelight fixed door unit. So this is all going to be made by the door company, which leads me to believe it's probably not going to have an NFRC rating like these windows. So I've got to think, what am I going to do? Am I going to ask the client for an NFRC rating, or am I going to take a default value? Let me know what your opinion is in the chat window. Default value or NFRC value. Anyways, let's keep doing our takeoffs here. I've got a 7 square foot side light on either side of this door. So I'm going to input that as 7 square feet. This door is, it looks a little wider than normal. So that's a 3'4" door. 3.33 feet times 6.67 feet gives me 22.2 square feet for that door. It's a little odd. Yeah. I also have a transom window up above there, and I've determined that that's 8 square feet. So 8 square feet on the window above. I'm just working my way around. Let's go back to the floor plan because I can grab that information faster on the floor plan. Oops. Where did, oh, that's not good. My plan disappeared. So, all right, you're going to see me scramble here. I'm going to switch screens and I'm going to go to my folder where I have all this information and re-grab this and open with Bluebeam. Occasionally I get that. Does anybody have ever had Bluebeam crash on you? So I'm just going to recover that plan. Good. So it looks like Judy says, I would ask if there's an NFRC rather than assuming there's not. Yeah, good point, Judy. That's a good way to go in this case. Since I don't have any client information, I'm going to lean more towards, I'm going to take a default value, assuming a worst case there. But yeah, if you need a little extra compliance credit or not taking a compliance penalty, including that NFRC value, if it's there, is a great way to do it. So, all right, I've got another pair of 2636 windows. Those are, I'm going to call it a 5036, which is 17 square feet, 17 and a half square feet. And then our next window here on the front is a pair of 3050s. So that's a 6050. I'm going to call it 30 square feet. Now, if all of those windows were the same area on the front, I could lump them all in, or the same window type on the front, I could lump them all into one window area. That's perfectly legitimate. Now, later on, I may want to take advantage of the shading, and in that case, I want to enter windows separately. So let's go to our left wall. Just take a look at here. I only have 2 windows on the left face, and both of those are 2040, so 8 square feet apiece. Our back wall, we've got a few windows and doors across the back that we need to account for. A 305 window, that's 15 square feet. I've got a door on the back. Now, it says tempered safety. It would lead me to believe that is a glazed door, but I'm going to look at the elevation and see if that actually is a glazed door or not. It appears to be a solid door. You can see on that elevation. I'm going to switch back to my Bluebeam screen. That door appears to be solid. So, that might be a question I might want to ask the client. Hey, did you intend to make a solid door, or was that just an error? So right now, I'm going to assume it's a solid door, and then make a note to my client and ask them about that. So it's a 2668, which is 16.7 square feet. My next window is a 6068, 40 square feet there. 3060, 18 square feet. Sorry about the jumpiness of Bluebeam. Seems to be acting up on me today. 6080 slider between those two 3060 windows. That's 48 square feet. I have another 18 square foot 3060 window. And when I say a 3060, I'm talking about nominal dimensions, 3 foot wide by 6 foot high. That's a typical nomenclature there. And then another 6068 40 square foot slider there. We only have one pair of windows here on the right elevation, 2640s, which is a 5040, which is 20 square feet. And I'm done with the house window takeoffs and door takeoffs. I don't see any skylights. I could go through to the roof plan and verify that if they had included anything there. Let me get to the roof plan. There's a foundation plan. There's a roof plan. I don't see anything. So again, I like to verify that just to make sure, because sometimes if you get a really busy floor plan and a lot of information, it's hard to see that. And it could be a miss on that. Get a plan check back. Let me know if you've gotten plan checks back from projects that the plan checker called out you missed something and you actually had it included. I'll share with you, maybe if time allows, some of my experiences. Let's see, my garage doors are 10 foot by 7.5 foot. So 7.5 times 10 is 75 square feet. I've got 2 of those doors. My left wall, I've got 2 3040s, which is a 6040, 24 square feet on the left wall. My rear wall is a 2868 door. And again, I want to look and see if that's a solid door or a half-light door. It really does make a difference if you have a fenestration product in a garage, believe it or not. It does make a difference if you have insulation in walls and ceilings in a garage. So give it a try if you don't believe me, or let me know in the chat window if you've tried it and you've seen a slight difference in the proposed design. So this one looks like a solid door. I'm going to say that that's a 17.8 square foot door. And then my right elevation here, working our way around, we're just about done with our takeoffs. 2 3040s at 12 square feet apiece. So good. Now, I've got my takeoffs. I've got all this information on my sheet here, updated a few dimensions and areas, and I'm ready to start input. Now, we're going to start a CBECC-Res project completely from scratch. So you'll see here, I've opened CBECC-Res on the screen, and we've got a blank project. So the process for creating components and everything in CBECC-Res is multiple phases here, multiple steps. First thing you want to do with CBECC-Res is create an object, create something. In this case, we need to create a project. So our first step is create the project. Then we're going to name the project. This is going to be simple new construction, right? And you can name it anything you want, maybe your client's name or the subdivision name, whatever you want to do that. Then we want to define it. So we create it, name it, define it. So in this case, our project is located in climate zone 12, which is a pretty hot climate zone, has a little bit, quite a bit of heating as well. So now, a few particulars with CBECC-Res is that it always wants an address. So I'm going to call this 1, 2, 3, 4 construction street. You're going to enter your project information. This one is in Tuolumne. Spell that, right? 95379. Anybody ever been to Tuolumne, California? That's lived there for many, many years. All right. The next thing we want to do is click on the Analysis tab. Now, the run title, you can input the information here or not. It's totally up to you. I'm going to leave it blank. This is a one-off house, so not going to do anything. Here, our analysis report is going to be a building summary, newly constructed. Now, if this were an addition alone or an E plus A plus A, I can redefine that here. But in this case, new construction. I want to generate both a PDF report, and if you're going to be uploading this to a HERS provider registry, since it's new construction, you're going to need that XML file. I'm going to run the simulation speed as compliance. You can also change it to quick if you wanted to just run a quick simulation, but in order to generate the uploadable document, you need the compliance version. And I'm not participating in a program. So I don't have PV, I don't have battery. I'm not going to add any notes, but I do need to input some information on the building. So I'm going to call this my building description. It's what's going to show up on the zone information. It's going to show up on your CF1R. I'm going to call this Code and Coffee. It might be an address. It might be some specifics about the project. I'm going to leave the air leakage status is default, which is 5 ACH at 50 Pascal. My insulation construction quality is standard. If I set improved under the 2016 standards, that means it's QII. So keep in mind, 2019 code is right around the corner. QII is going to be a prescriptive requirement. So I'm going to input my front orientation. If you remember, that's 143 degrees. I'm going to input the number of bedrooms. Anybody remember how many bedrooms was in this project? Let's bring up our blue beam floor plan. So I see 3 bedrooms. Yeah, so we're going to input 3 bedrooms there. Now, tell me in the chat window why it's important to enter the number of bedrooms. Who cares, right? Why is the number of bedrooms important? What does that do? So in this case, this is a rural project. There's not any natural gas. So in that case, I'm going to uncheck natural gas is available. It's going to default to propane in this case. I don't have any other inputs I need to deal with other than indoor air quality and cooling ventilation. So indoor air quality is my fan that runs a little bit continuously or intermittently, and my cooling ventilation is a whole house fan that would run during different times of the year to cool the house down. So I see Casey says ventilation requirement. Judy says occupants. You both are correct. The number of bedrooms determines the number of occupants in that house. So it's the number of bedrooms plus 1, and you use that to determine what the IAQ fan CFM rate is. In this case, I'm going to use a default. I could specify a fan, but I'm going to use the default. This is kind of different than Energy Pro. Has that default fan selection. I'm going to, I can go in here and create a fan if I specified one. If I didn't specify one, the software just says, look, I'm using the software or the calculation CFA, condition floor area, over 100 plus 7.5 times the number of bedrooms plus 1. So whatever that is for this house, that's what it is. If you entered a specific one or use the central fan integrated, you're going to want to input indoor air quality fan there. So in this case, this house is using cooling ventilation, but I need some other information here before I can input that. So software is going to default to that, and we'll get to that as soon as we get some information there. So Boom, there we go. We hit OK. We have a project. We have some construction files underneath that, but nothing else. So now what we need to do is we need to create a zone. So this house has, I did say it has an attached garage, right? I didn't. This house has an attached garage. I need to define that here in the project information. Hit OK. I'm going to create a zone. I'm going to create a house zone. In this case, I created it. I'm going to name it. I'm going to name it house since it's only one floor. If it's the first floor, you can name it first floor or second floor. It belongs to the parent component, which is the project. There's 1,638 square feet, and we need an average ceiling height. Now, we have a vaulted ceiling. I'm not going to go into the details here, but we can grab that volume from the vault, add it to the volume of the house, and then divide it by the square footage of the house. That's going to give us an average ceiling height. So in this case, I've already done that. It's 9.4 feet. That would be average ceiling height throughout the entire project. That's going to vary based on your project, whether or not you have a vaulted ceiling. Now, it's going to automatically generate this zone. It says it's 1,638 square feet, one story, average ceiling height of 9.4, floor to floor height. You know, really what it defaults to is 12 inches greater than the ceiling height. As long as that floor to floor height was greater than the ceiling height, the software is going to run. My window head height is 6.67 feet, 6'8" there. I'm not going to worry about my HVAC system yet or my water heating system yet. I'm going to input that in a little bit. So I'm going to go ahead and say OK. So you'll notice that it creates a house zone as well as a garage zone. We're going to deal with our zones first. We're going to develop the house zone and the garage zone. Then we're going to start inputting our opaque surfaces in fenestration. So I'm going to right click on the house zone. I'm going to say create. I'm going to first create a ceiling below the attic since this is a vented attic. And you'll see why in a second. I could go through and create an attic first for that, but this is going to be a much faster way to do that. I'm going to say I'm going to name this. I'm going to leave the default name ceiling below attic 1. That's fine with me. I don't really care. That ceiling covers the entire house. So I have 1,638 square feet. My construction assembly. Oh, guess what? I have no construction assemblies. I need to define that. So in our plans, this particular project, I told you I already have all the assemblies taken off. So I'm going to tell you what it is rather than going back and forth to the plans. So in this case, our ceiling construction assembly consists of an R38 ceiling. And that's a ceiling below an attic. So I'm going to create it. I'm going to name it. I'm going to define it here. So in this case, it's an R38 ceiling. The ceiling is below an attic. It's a wood frame ceiling. There is no attic floor. If you had, let's say, a HVAC platform over a certain area, you could add that here, add some sheathing decking on that, designate a particular area for that. In this case, I'm not going to do that. We have R38 in that cavity. I'm going to click on R38. I'm going to make sure my frame path matches what my plan says. It defaults to 2x4, 16 inches on center. I have trusses 24 inches on center. I'm going to select that. There is no sheathing insulation on the inside here, and then my inside finish is going to be gypsum board. So I don't have a raised hill truss, and I'm not using spray foam insulation. So I'm going to hit OK. So I've just defined that construction assembly. Now you'll notice that when I hit OK on that, it's going to automatically generate my ceiling below data dialog box. So basically it says that this belongs to the house. I have it in the attic zone, and I have R38 ceiling. That's my construction installation. Construction assembly, and then my area there. So I hit OK. It created this. It also created an attic in the project, the attic that covers the entire house. So I want to double click on this attic to make sure that it's configured correctly, meaning that did it match the roof pitch. In this case, our house has a 6 and 12 roof pitch. You'll see here in the section here, there's an indicator, 6 and 12. So I'm going to go back to my roof rise, 6-inch rise and 12-inch run. It also defaulted to an asphalt shingle construction assembly. That's what CBECC-Res does. Now, I'm using a metal roof. That metal roof really has the same characteristics as an asphalt shingle. But I'm going to go through here and create a metal roof assembly for the house, because this house is going to have below roof deck insulation, which is not going to be the case over the garage. So we're going to create this assembly. So again, we have an attic roof. It's a wood frame ceiling. The type is steep slope roof, metal tile, wood shake, other. So right here I'm using a light roof. We could use metal tile. Above roof deck insulation, none. Roof deck is going to be a normal wood sheathing. My cavity insulation, we're going to use the R18 below roof deck strategy. That's option B under package A. My cavity frame path is going to be a 2x4 top cord, 24 inches on center. And there's no finish on the inside. One other thing that I want to point out here is that I'm using R18 insulation. That's about a nominal 5.5 inch deep insulation. I'm putting it in a 2x4 cavity. That means I'm going to have some insulation sticking out below that framing. So in that case, if they fill in that void of the framing, I can click thick insulation cavity insulation covers framing. So that just means that insulation is going to pillow out between that framing member and cover it completely. You get a slightly better value there. You'll see that it goes from a 0.058 U factor to a 0.052 U factor. If that's the case, that's the installation practices they're using. Go ahead and check that box. I've got no cool roof. The default value for a house without a cool roof is a age solar reflectance of 0.1 and thermal emittance of 0.85. That's a default value. So I'm going to say okay. I've created that attic. Now I have a garage zone here as well. I'm going to go ahead and double click on that garage zone. It automatically assumed that that garage was a 20 by 20 garage, which is not the case. My garage is actually 774 square feet. And it says that, oh, that ceiling is 10 feet. No, it's not 10 feet. It's 9.5 feet. So this is really getting into some minutia here, but I'm going to enter the volume of 7353, right? The bottom of that slab is above grade 8 inches, 0.67. So you could leave it at 0 if you like. So now all of a sudden I have a garage and house zone. It's saying that I have an attic over the house and the garage. I want to create another attic because I don't want to put below roof deck insulation above my attic. So what I want to do is come through here and create another attic. I'm going to define that attic. So I enter that attic. I'm going to say that that attic 2 is going to be above my garage. So what I need to do is create a ceiling below my attic space. So ceiling below attic number 2, parent component garage. I'm going to create a brand new object. I'm going to say that that area is 774. I'm going to create a brand new construction assembly. I'm going to call it metal roof garage. You know what? I'm going to copy that data from the R38 ceiling. I'm going to say garage ceiling. Sorry. In that case, it's the ceiling. I'm going to copy it and just go in here and just say, look, just make that R0, no insulation. I'm done with that. Hit OK. Now we have a ceiling below that garage. Now we can come in here and say, look, it automatically put this all together. I have 0 above that. I need to go in and define what that ceiling is. So it's saying that the attic zone is attic. I want to say that the attic zone is attic 2. So that's how I'm going to separate those two ceilings, right? So I also need to go in here and say that my construction for my attic over the garage, I could change instead of attic 2, I could say attic garage. That's a little bit better. Is not the metal roof house. It's going to be the metal roof garage. Have I lost anybody yet? Let me know what you think so far. So basically all I'm going to do is get rid of that insulation below roof deck, uncheck that cavity insulation covers framing for that new assembly I created, and say okay. Okay, so now I have an attic over the house, an attic over the garage. I've got my 2 zones, everything's configured right. I've got a roof over both zones. Now I can start entering my walls and windows. So it's always a good idea to save your projects. I'm going to call this live version. Save your projects on a regular basis. CBECC-Res, can have ability to crash now and then. So Olivier says, looks like garage ceiling went back to 38. Let's take a look at that. So yeah, so my construction assembly is garage ceiling. I could change it to R38, but I went ahead and defined that here. Now, you'll see we're starting to populate those construction assemblies. All of those assemblies I've created so far are in your construction assembly folder. So you can go through and redefine these. Now, if you want to change something globally, go in and change the actual construction assembly. Rename it, change it. If you want to create a new one and redefine it for a certain area, make a new one. So those are kind of the tips and tricks about CBECC-Res. So I'm going to start entering my wall areas. I'm going to enter exterior walls. So again, create, name. I'm going to call this front wall. I'm going to define it at 450 square feet. I'm going to create a wall assembly. This wall assembly is going to be exterior wall. You can call it anything you want. 2x6 wall. In this case, inside cavity path, no sheathing insulation, cavity insulation. I'm going to call this R21. 2x6s, 16 inches on center. There's no sheathing insulation. My exterior finish is going to be wood siding. Good. 0.066 U factor. I'm going to say OK. Now I'm going to create that wall assembly. I need to define the orientation. Now we set the orientation of 143 degrees in our project. I'm going to say that this wall is the front wall. It's another really nice feature about CBECC-Res is that there are some really neat features in here. So as I'm talking, I'm just going to enter this information. Let me know if you have any questions. So I'm going to copy that data from the front wall. So really simple. All I'm going to do is change the area to 252, and I'm going to change the orientation to left and hit OK. You'll see this is going to go really fast from this point on. Since all these walls are the same, all I need to do is just copy information. Copy it from the front wall, change the area, 617, change the orientation to back, say OK. You can see I'm going really fast. I would say this is as fast as Energy Pro. Let me know what your opinion is. Kevin says, what are your thoughts on 24 inches on center? I think 24 inch on center framing is great. They There are some advanced wall framing practices. One of the issues there is you just want to make sure your client realizes that that's what you used, because their framers may just be, blasting through 16-inch on center, and there's a little extra thought that needs to go into 24 inches on center framing. Like, hey, I need to align that framing under a rafter or under a truss or floor joist. So just keep that in mind. I'm going to define the exterior walls as garage front wall. So again, you could go through do all your walls first, or do each wall and windows, however you like to do this. But I'm just going to do all my walls first. 266 on that front wall. Now I'm going to make a new assembly. I'm going to call this garage wall, just so my plan checker does not confuse this with an exterior wall. I'm just going to copy my exterior wall and go through and just say, look, there's no insulation in that. Still the same configuration, just has a much worse U factor. So done, hit OK. It's the front wall. Again, area orientation. Don't forget to do that, because if you allow CBECC-Res to default, then it's going to mess you up considerably. Olivier says, I think copy paste in EnergyPro is a bit faster. Yeah. Now, I can copy and paste in CBECC-Res, but you're right. Sometimes EnergyPro is a little bit faster. Garage left wall. This is all, oops, I'm going to call that garage. I'm going to copy from that, change that to 200, call it a left wall. So hopefully we're going to get this show in 1 hour. I'm going to turn up the speed here. Garage rear wall. These are just user input names, so you can call this anything you like. So my rear wall is 114, call it rear or back. And my last garage wall is going to be my garage wall. Keep in mind, CBECC-Res likes a unique name for every component. If you don't, it's going to send you an error. So make sure that you use some sort of naming convention that allows you to name all those surfaces and components separately. So, all right, we're going to go back through and start creating windows, window inputs. I'm just going to use the default name, window 1. It's good enough for me. I'm going to enter this one by window area. You can have two ways to do it. If you're going to use overhangs and side fins, guess what? You have to use window dimension method. So in this case, I have a 17.5 square foot window. It is an NFRC 0.32, U factor 0.25 SHGC. I'm going to say OK. My next window is that side light. Remember in our takeoffs, we went to that, and I told you I'm going to use a default value for that. Here is the process that I would go through for defining that default value. So I'm going to enter a window. I'm going to call it window 2. I'm going to enter it by window area. I'm going to say it's 7 square feet. I'm going to change this to default. Now, CBECC-Res does not have a lookup for defaults. What you have to do is you have to go to the standards. So I'm going to bring the reference ACE over here. I told you that I would demonstrate this. And I'm going to go to table 110.6A and B, and that's going to be in the part 6 portion of Title 24. That's subchapter 2, so 110.6. And I get my table here for U factor. That is a non-metal fixed double pane. So I have a 0.55 U factor, and I go down to 110.6B, non-metal fixed clear double pane, 0.67 SHGC. So now I'm going to go back to CBECC-Res and input that information. So I'm going to say that that U factor is 0.55 and the SHGC is 0.67. So maybe I'm going to make a recommendation that the 2019 software have lookup tables. What do you think about that? Would that be nice? Would that be a helpful tool? So I'm going to copy that. So I'm going to say copy, paste. So I have two of those windows. So I can change this to window name to window 3 if it makes everybody happy. I'm also going to paste that window for my transom. I'm going to call that window 4, and that was 8 square feet. Good. Everybody, Luke says yes. All right. Hey, welcome, Luke. Let's see. We have a question for exterior wall assembly. Does Title 24 allow for corrugated sheathing with light gauge studs? Yes, you could do a metal frame, but what's going to happen is your U factor is going to be ridiculously high. It's not even going to meet the mandatory requirements. So in that case, you're going to want to add some continuous insulation. Siding really doesn't matter. It's going to be wood sheathing or other. If it's stucco, that's one choice. Wood sheathing or other is the other choice. So yeah, so that's really the only thing you have. So good. I'm good to go with those windows. On that, I'm gonna copy this window because I know this is my NFRC window, and I'm gonna call that window 5. So we got lots of ways to enter windows. So in this case, I'm gonna use the window dimension method. I'm gonna say that that's a 5 by 3.5, and it says, oh, I'm gonna do the math for you. And if I had multiple windows, I could give it a multiplier. So so I'm going to do that again, but I'm just going to use the Control-C, Control-V method. So, and that's going to be Windows 6. So sorry about the herky-jerkiness of this here. That window is a 6050. So I'm going to just change those dimensions to 6 by 5. Look at that, 30 square feet, good to go. I'm going to go ahead and create these new windows for the left wall. I'm going to enter these by area. This left wall has, if you remember, it has 2 windows that were 8 square feet apiece, right? Actually, if I do the window dimension method, if I do 2 by 4 is the size, 2, and I say that there's 2 of those, it's automatically going to do the multiplier. So I'm going to take that off. Rear wall. I've got quite a few windows on this, so let me just go through. Let me know if you have any questions. Otherwise, I'm going to just keep talking, and you can let me know if I've made any mistakes. I've been known to make a mistake or two. So I'm going to just do the Control-C, Control-V, window 9. You see CBECC-Res has a really strange way of entering names for windows. If you duplicate something, it automatically changes it. So I'm going to go back to create method, window 10. Let's see, I'm going to copy the same data from window 1 since that's our NFRC value. Window area is 18. So if you remember, if you're following along from the beginning, I've got 2 windows flanking a sliding glass door. So, and that sliding glass door was 48 square feet. I'm going to enter area, 48. So, say OK. You can see how quick this goes. I'm just going to copy that window 10 since it was the same window as the other 18 square foot window. Oh, I had a conflict, so that's not window 11, that's window 12. So one thing I like about CBECC-Res is that it gives you those nice errors on the fly so you can correct it. One more sliding glass door. I think this is a sliding glass door. Yep, so I'm going to copy window 9. Now, you could go in and say that this is window and call out the size. That's a good way to go. Then they're easily identifiable from your tree here. But however you like to do it, I'm really not particular. I just like to go for speed sometimes. But if it helps you later on when the client decides to revise something, you can say, oh, window 6040 window 1. You can do that. Now, you can go in and define window types here. If you need to change U factor in SHGC or change multiple types, that would be a great way to do it rather than identify each one of these at the window. So I'll get into that into a more advanced version of this. So we need to enter some doors. I'm going to create a door for the front door. I'm going to call it front door. And it belongs to the front wall. What did I say that was? 22.2 square feet. So I'm running out of time here. So I'm going to speed this up. We have a rear door. I'm going to call this back door. Everybody doing good on time? That was 17.8. Again, if I enter a solid core door, the CBECC-Res is going to default to a solid core door. You may have a better U factor for that door. 2019 code is going to make exterior doors a prescriptive requirement to be a 0.2 U factor. So keep that in mind. Okay, let's enter our garage doors. Then we're going to get back to a few other things. I'm going to call this garage door. It is 75 square feet. It's going to have a U factor of 1. I'm going to say Control C, Control V. Left window, window 15. Now, these windows will show up on your CF1R. I had a comment from a plan checker who said, your window area is too high. Well, look, it included the garage windows. Has anybody ever gotten that comment from a plan checker? You might want to point out that, sorry, I can't type and talk at the same time. I haven't developed that skill. You can show them that those windows in the garage are associated with garage walls, and they can subtract that from the overall glazing, and it's not included in your glazing area. So this is a solid door. Good. All right, one other window in the garage, and I'm going to get back to my Olivier said that he had that happen once. So yeah, I'm going to get back to my demising walls. So what was that? I'm just going to group these two 304Os together. So I'll just call it good. All right. I need to enter my demising walls. Now, demising walls are the parent component, or the demising walls always belong to the condition space. You can't enter a demising wall in the garage from CBECC-Res. You can in Energy Pro. The software is going to throw an error on you, though, and you're going to wonder why. So I'm going to call this demising wall. The parent component is the house. The area is 198 square feet. The construction assembly, need to make one. We'll call it R21 demising wall. And we're going to say, okay, we're going to go through here and say gypsum board, cavity insulation, R21, gypsum board on the other side. Say, okay, done. All right. What does that surface, what is the surface on the, or the zone on the other side? That would be the garage. So it belongs to the house and it's adjacent to the garage. You hit okay. We need to put a door in there. Create a door. That door is going to be 20 square feet. Doesn't matter orientation for demising walls. It's going to have a 0.5 U factor. Now, if you forget some of this stuff and try to hit analyze, the software is going to come back and say, look, you made an error somewhere. So one more interior surface. That's going to be the knee wall, right? I'm going to call this knee wall adjacent to the attic, right? So the parent component is house. I've already determined that that was, what, 22 square feet. I'm going to create a new assembly. I'm going to call that assembly R21 knee wall. I'm going to copy that data from the demising wall, say okay. What I'm going to do is I'm going to take this other side finish off. There is no finish on the inside of that that attic. Now, if you're doing QII, you'd want some sort of finish on there. So, oops, sorry, forgot to change that to a 2x6 wall. The zone on their side is going to be the house attic, not the garage attic. Now I need to go in and fix my R20 and demising wall because I forgot that was a 2x6 wall. So boom, done. All right. Anything else? I made the mistake when I initially did this project. I need a floor. So this is a slab floor. If you forget to put in a slab floor, what's going to happen? The software is going to run. We got 6 surfaces on all these, and the software will run. If you do, you're going to see a really, really bad proposed design. It's going to fail by a large margin. So make sure you don't forget floors. 1,638 square feet of slab. This is 0.67 feet above the ground. I need 186 lineal feet of that. I'm done. Default on that, no slab edge insulation. I need to put a floor in the garage and jump to my mechanical systems, which will go super fast. Area of the garage 774. Elevation above grade is 8 inches, and perimeter is 89 linear feet. Good. I'm done with my envelope to enter mechanical systems. Now, you can enter your mechanical system on this heating tab, but you have to enter the mechanical system from your zone. So you need to go to the zone, double click on the house zone, select create new HVAC system. I'm going to call it HVAC system 1. This is it's not a heat pump. It's not a variable outdoor air ventilation central heating and cooling system. It's going to be heating, cooling, other. So in this case, I'm going to define my heating system. I have one heating system. I'm going to say that that is a gas-fired furnace. I'm going to set the AFUE at 92 because I know that's my client likes to use. I'm going to define the cooling system that they're going to use a split AC with a 14 SEER, and I'm going to use the default 1170 ER with the AC charge verified. I could change this. I could go in and say it has a higher EER, but in this case, I'm going to leave it as the default. Just say okay. Define my distribution system. This is my ducts. My distribution is going to be ducts located in the attic, and I'm going to use the default sealed and tested R8 in those ducts. Now that's pulling right from the package A, table 150.1a. The last thing I need to do is create a fan system for that, and it's going to make it a default. I only have one choice, single speed PCS fan. Hit OK. My fan efficacy is going to be 0.58 watts per CFM. Don't change that. Don't make it lower. You're going to set really obscene targets for that HERS rater to hit. Now, you can go through in each of these tabs and look, but really what I've done is I've defined everything for my HVAC system. All I need to do is my water heating system. I'm going to call this standard distribution, create a water heater. I'm going to call that water heater a gas tankless. I hate the term instantaneous, but I'm going to say that that's a 95 energy factor. We'll say 0.2 gallons. You don't need to deal with recovery efficiency unless you have a hydronic space heating. That's it for my water heater. I'm done. I need to go back through and go to my mechanical tab. I need to enter because I said I wanted to do a cooling ventilation. And guess what? Now I have some inputs here. My default whole house fan in the house is exactly what I want it to be. If you don't want one, you got to go back through and say that this is none. So CBECC-Res defaults to that. I also need to define that fan. Otherwise, it doesn't have any information there. So I'm just creating a whole house fan. I'm using the defaults. This is default based on 1.5 CFM per square foot of conditioned floor area. And my fan power is 0.1 watts per CFM. That's the default. If I hit OK, I've got a whole house fan. Guess what? I'm done. I'm done, and I'm just over an hour here. Anybody have any questions? I'm going to switch views to my over-the-shoulder shot. I know that was really fast, and through the magic of TV, since my software won't allow me to run the analysis without crashing YouTube, it's a bummer, but I would love to be able to run the analysis. But what I want to do is go to Tools. I want to view my compliance report. If you're to run this project, you're going to see that the project complies. Yahoo, we did good. We can go through and check climate zone 12, 1,638 square feet of conditioned floor area. My front orientation is 143. Natural gas is not available. It complies. Not bad margin there. Looks pretty good. Number of bedrooms is correct. 3 bedrooms. Average ceiling height is correct. We could go through and verify that all of these orientations, the wall areas are correct. You can see I've labeled my garage walls so that the plan checker can get rid of those. I have an attic over the house, attic over the garage. No cool roof, 6 and 12 pitch. I'm looking good so far. So I have a comment in here. Lots of homeowners request to get rid of the gas furnace and change the entire house to electric. Yes, mini split is allowed. Mini splits can incur an energy penalty because of the way the Energy Commission classifies those. So it's going to look at it as if it's a minimum efficient air conditioner with ducts in the attic. So JC and Eli's dad says code only requires some kind of heating, not specifically to type. Yes, as long as you provide heating to the design specifications according to the building code, you're good. So good. And Kevin says never record plan package. Where do I grab one to review this? Not sure. Never received plan package. Oh, Kevin, email me. I'll when I do a wrap up, you can email me. I'll share that email address, and you can do that, and I'll send that to you. So here's our window information. Here are our opaque surface constructions. We can verify all that. Here is our water heating system, small tankless, 9.5 energy factor, heating and cooling furnace, 92 AFUE, 14 SEER, 11 EER in the cooling. And we'll see that we have a whole house fan required, as well as a calculated our indoor air quality fan. Woohoo, I'm done. Everybody clap your hands and do that, wipe your brow, and know that we finished this project. Good. Little bit over an hour. I apologize for that. I see we have a couple other questions. Olivier says, any plan on doing a co-hosted CBECC Code and Coffee with Luke Morton someday? Would love to. Luke, I'm going to bring my Code and Coffee to you soon, and we'll do a side-by-side and have a back and forth. Maybe we'll make it an advanced class. We'll tackle some of those tough issues that you're really good at. So good. I hope this was helpful for those of you who either are CBECC-Res users or are going to be CBECC-Res users, or maybe you're an Energy Pro user and wanted to see what those other energy consultants are doing with CBECC-Res. So, hey, it's good to learn. I'm always learning. I'm always trying to figure out new ways to capture information. Wanted to just say goodbye. I want to leave you with some info here. We do have some more information on this at our Energy Code Ace website. You can reach me via email at AceTV at energycodeace.com. Zach, did I get that right? I always forget my own email address. So it's AceTV, ACETV at energycodeace.com. It's in the description of this class. I would really appreciate a couple things. If you like this show, hit the thumbs up button, right? That lets me know that, hey, this is great. Please provide comments. I love comments. I try to respond to all those comments personally. Also, ring the bell and subscribe to the YouTube channel. That way you get notifications every time we post something new. We're going to be delivering additional non-live episodes of Code and Coffee. I'm going to be going through some of the non-residential dynamic forms, prescriptive forms. We'll be doing other stuff. So anyways, hopefully this is helpful to you. Hit the thumbs up and subscribe button. I want to wish everybody a wonderful day. Thanks for tuning in to the live broadcast, and we'll see you next episode. So have a wonderful day.